Hey everybody, today we're going to be starting, actually it's been a while since I did a video, I think it's been a few days, so I guess this is good to make another one. Alright, so today we're going to work on the first section of Unit 6, so this should actually say 6-1, which is ratios and proportions, because this whole unit is about similarity, and you're going to see the connection between similarity and congruence, which we talked about. So congruent shapes were the same shape and the same size. Similar shapes, and we've alluded to this earlier this year, similar shapes are the same shape but not necessarily the same size. And we'll get into that more specifically during session. But I thought today in this video we would talk specifically about how to work with ratios, proportions, and cross products, because that's how we're going to solve most of our similarity problems. So that's going to require a little bit of vocabulary. So ratio, okay, ratio is actually one of the most important things. A ratio is a comparison of two quantities using division. Okay, so a comparison of two quantities using division. Now, ratio can be written a few different ways. You can have it as x over y, or you could have it as x colon y, or you could have it as x to y. That's three different ways of writing a ratio. Okay, I don't think how that's right. Hold on a second. This table is making it all bumpy. Hold on a second. That'll be better. There we go. Okay, let's do this example. In Logan's High School, there are 190 teachers and 2,650 students. What is the approximate student-teacher ratio at this high school? So student-teacher, so students is going to be the first number, so 2,650, 190. Now we can simplify that. They're both divisible by 10. We know this because they end in a 0, so we can cross that out. So it's going to become 265 over 19. Now, can 19 divide 265? I don't know. I'm going to cheat. We're going to use a calculator. Divide by 19. No, it doesn't divide it evenly. And 19 is a prime number, so that is our ratio in its lowest common terms. So there you go. So this is the number of students to teachers. Our proportion. So a proportion is going to be an equation in the form. Okay, so yeah, here we go. It's basically an equation with two ratios on either side of it. It's when you're comparing two ratios together. So I'll write down the book definition because I like to have the book definitions when we're doing these. An equation of the form A over B equals C over D states that two ratios are equal. Now, what does that mean? It's when we take two ratios and set them equal to each other, right? And that's how we're going to solve almost all these similarity problems. And we'll get into the specifics of why that is the case. Okay, cross products. Cross products is basically how you solve a proportion. Okay? So let's see, cross products. Where are you? There we go. Okay, so I'll give you the book definition and I'll explain it in a little more layman's terms here. So in the proportion, A over B equals C over D, where both B and D are non-zero numbers. Because that'd be imaginary, that would not work. The cross products are AD and BC. The proportion is true if and only if the cross products are equal. In other words, we used cross multiplication to solve this proportion. So for those of you who are a fan of, excuse me, for those of you who are fans of cross multiplication, you're probably going to enjoy a lot of the stuff we do here in this section. So let's go ahead and take a look at this. So we got 6 over x and 21 over 31 and a half. Okay. We're going to go ahead and solve for x here. So we're going to cross multiply. And again, we're going to cheat. Well, not cheating. I guess we're just going to be slightly lazy, I guess. So x times 21 is going to be 21x. And then 6 times 31 and a half. I don't know what that is. 6 times 31 and a half. 100 something, 180. Yeah, 189. There you go. And then we're going to divide both sides by 21. And I'm assuming that's going to be 9. Looks like 9. Let's just double check. Yep, it's 9. X equals 9. So there you go. Most of you, I think, remember how to do this. I'll leave that on the screen for a second. Okay. And then over here. So here you actually don't need to cross multiply. We're not going to cross multiply here because we have x in the numerator. And I mean, you can cross multiply, but it's just adding an extra step. I'm just going to multiply both sides by 4. I think that makes more sense here. Why make more work for ourselves? So x equals negative 44 over 6. Those are both divisible by 2, so x is equal to negative 22 over 3. So that works. If I wanted to write it as a mixed, that's an improper fraction. If I wanted to write it as a mixed number, that would be negative 7 1/3. So either one of those is fine. So you'll notice you could cross multiply and get 6x equals negative 44, then divide by 6. You can do that. Just why do that in that case? I mean, you can, but why are you making more work for yourself? Okay. All right, let's do some more of these. So we're going to cross multiply here. All right. So we have, no, again, you know what, we're not going to cross multiply there. Yeah, why are we going to make more work? Again, there's a multiply by 2 because 2 is in the denominator. So we're going to get x plus 3 here equals 8x over 5. And no, actually we're going to cross multiply. Forget that. It was a terrible idea. Terrible idea. Okay, we're going to cross multiply. We don't want to have a fraction on this side. That's why. All right, that's right. We don't want to have fractions on this side. We have another term there. Okay, so we're going to have 5x plus 15 equals 8x. Okay, now it's making sense to me. All right, I had to wake up there. And we're going to subtract 5x from both sides. That's why we're doing that. Okay. And 15 equals 3x. Divide by 3. Oh. And then x is equal to 5. Okay. Let's take this one. So cross multiply, we're going to have 9 times z minus 1 equals 7 times z plus 4. We're going to distribute these numbers, so go ahead and distribute that. And here too. So 9 times z is 9z. I have to write a little smaller so I can fit this. Minus 9 equals 7z. Oops. Plus 28. Let's get the z's on the same side. So I'm going to subtract 7z from both sides. There's a lot of algebra, isn't it? It's basically all algebra here. 2z minus 9 equals 28. We're going to add 9 to both sides. I might only have to use this space here, I think. Yep. Plus 9 here. And 2z is going to be equal to, let's see, 37? Is that right? Yeah, 28 plus 9 is going to be 37. Divide by 2. I don't think I made a mistake there. Pretty sure I didn't. And z would be equal to 37 over 2. Or if I want to write that as a mixed number, it would be 18 and a half. Yeah. Okay. All right, let's see this one. I'm going to cross multiply here. I guess back, you know what, in this example here we should have cross multiply just to stay in. We're going to end up with the same thing, but I think it probably would have been a better idea to stay in the good habit for these other problems, so apologize for the confusion there. We're going to cross multiply. So 2 parentheses x plus 2, and 3 times 5 is 15 x. So distribute these. We're going to get 2x plus 4 equals 15x. Subtract 2x from both sides. 4 equals 13x. Divide by 13. And x will be equal to 4 over 13. Is that right? Yeah, I guess so. Okay. Let's check these up here. So, okay, this is interesting. We have a negative sign in front of us. You have to be careful when you're doing these. This negative sign has to be attached to one of these numbers. I'm going to go ahead and cross it out and make it -4, so I know which one is negative. You'll see why we do that. So we're going to go ahead and cross multiply here. So -4 is equal to 2y plus 5. And technically you don't have to cross multiply here, but it's just better, trust me. 7 times 6 is 42. Now we're going to distribute this -4. It's really important that you assign that negative sign to one of those two terms. Okay. So -8y minus 20 equals 42. Going to add 20 to both sides. So -8x equals 62. Divide by -8. And x will be equal to -62 over 8. We can simplify that. Those are both divisible by 2. So x will be equal to -31 over 4. Or what's -7 3/4? Or 3/4, yeah. Oops, went the wrong one. Okay. And here we're going to cross multiply. So we're going to have 7 times z minus 3. And 14 times z plus 3. We're going to go ahead and distribute that. Okay, so 7z minus 21 equals 14z, let's see, 28, is that 32? My brain is like not functioning. Let's make sure that's 32. 42, yeah, good thing I checked. Alright, okay, let's go ahead and get z's on the same side. So minus 7z minus 7z. -21 equals 7z plus 42. And we're going to subtract 42 from both sides. So we're going to have 7z equals -63. And we're going to divide both sides by 7. And it's going to be -9. Yep, -9. Okay. Last one here, we're going to cross multiply. Now this is a negative sign, let's attach to the x up top. So we'll cross that out, -x. Same thing here, let's go ahead and make this the -5. Okay. So -x times 3 is going to be -3x. And then -5 times x plus 3. Let's go ahead and distribute. So -3x equals -5x. Plus, not a plus, minus 15. And we're going to add 5x to both sides. So we have 2x equals -15. Divide by 2. And we're going to get x equals -7.5. And that's it. Okay. All right, so we have an example here. Fernando conducted a survey of 50 students driving to school and found that 28 owned cars. If 755 students drive to school. Predict his total number of students who own cars. Okay, so let's try that again. Fernando conducted a study of 50 students driving to school and found that 28 of them owned cars. Okay, so of the people that are driving, 28 of them own the cars. So this is kind of interestingly worded. So 50 drive, 28 own the cars. If 755 drive, how many of those own their own cars? So not all these people own the cars, just like over here. 50 people drove, a little over half owned them. So we're going to know it's a little over half this. We're going to apply this ratio to this unknown ratio. So let's go ahead and write it out. I always like to do this in words first. So we're going to say owned over drive. Okay, so the people that own the cars will be our top value. The people that just drove will be the bottom value. So our first one, let's see, this is the owned value. So that's going to be 28 on top. And the drove value is 50. Okay. Now this ratio, 755 drive. So again, drive's on the bottom. And our let me zoom in here so you can see that a little better. Our unknown value is the top value. We don't know how many people own those cars. So we're just going to solve this through cross multiplication, just like before. So it's going to be 50x. And then 28 times 755. I don't know my 28 tables. Sorry. Let's go ahead and... That's a big number. So 21,140. So 21,140. Go ahead and divide that by 50. So we're going to say divide by 50, divide by 50, and divide that value by 50. So it's going to be a 20. Let's see. So 420. It's almost 423. Okay. So x equals 422.8. So that doesn't really make a lot of sense to me because you can't have 0.8 of a person. So I don't think this is a great example, but you get the idea. And our math is solid here. I don't think we made any mistakes here. So, oh well. Yeah, it's weird. It's a weird problem. I don't really like that example. You get the idea, but I don't like the fact it doesn't end up with a real person. Okay, let's try the next one. All right. In an experiment, students netted butterflies. That sounds like fun. Recorded the number of butterflies with tags on their wings and then released them. The students netted 48 butterflies and 3 of them had tagged wings. Okay. Predict the number of butterflies that would be tagged out of 100. So they caught 48. 3 of those 48 had tags. So if they catch 100, how many of them will have tags? All right, that's fair enough. So we're going to go caught over tags. You could do tags over caught, wouldn't matter. You're going to get the same answer, but this is how we're going to do it here. So caught is 48, tags is 3. Okay, here they had 100 caught, and we don't know how many of them were netted. I mean, how many of them were tagged. All right, so we're going to go ahead and cross multiply here. So we're going to have right there. Let's move this a little bit. Okay, so we're going to have 48x equals 300. And then we're going to divide by 48. And x is equal to, now we could simplify that, but let's just go ahead and save ourselves some time here. It's one of the advantages. All right, so 300 divided by 48. Yep, 6 1/4. Or 6.25. So again, it's another number that just doesn't, I mean, you get the idea, but the problem with these examples like this, you can't get an actual a number that makes sense because you can't have 1/4 of a butterfly, unfortunately, so the ratio isn't great. All right, let's try the last 2 examples. The ratio of the measures of an angle. This is a really good example. This is something actually myself and the teacher were talking about yesterday in a meeting. Because this is something you could see on a standardized test. This is just the kind of problem. The ratio of measures of angles in a triangle of 3, 4, 5. Find the measure. So let's draw a picture for a second. Right, so one angle, the relationship is 3 to 4 to 5. Now they don't tell you x, they don't mention 180 degrees, but we know all 3 angles have to add up to 180 degrees. And we're just going to go ahead and assign a variable. So 3x, 4x, 5x. So, yeah. Now, the funny thing is this is not really using cross multiplication, it's not using proportions, but we're going to, it does belong because it does mean ratios. So let's Let's go ahead and add these up. 3x plus 4x plus 5x equals 180. Okay, because we know the sum of the interior degree is 180. So that's going to be, what, 7, 5, 12. So 12x equals 180. We're going to divide both sides by 12. I like this question. And x is equal to, what, 15? Let's double check that, make sure I didn't screw that up. 180 divided by 12. 15, yeah, okay. So 15 is x. Now we're not done. So 3 times x would be 45 degrees, because 3 times 15. 4 times 15 would be, what, 60 degrees. And 5 times 15 would be 75 degrees. Let's make sure those all work. So 45 plus 60 plus 75 should equal 180, and it does. There you go. Okay. Last one. In a triangle, the ratio of the measures of the sides are 2 to 2 to 3. The perimeter is 392 inches. Find the lengths of the sides of the triangle. Okay, so the perimeter. So perimeter is the length around. So we know this plus this plus this is that. And we know their relationship is 2 to 2 to 3. So we're going to do the same thing. So 2x plus 2x plus 3x. So now we're going to add them, because perimeters when we add the sides together. So 2x plus 2x plus 3x equals 392. Find the lengths of the sides. So similar, only we're adding, and we're saying equals 392, because that's the perimeter. So 7x equals 392. We're going to divide both sides by 7. Okay. X is equal to, again, we're going to somewhat cheat here. So 392 divided by 7 equals 56. Okay, good, that one works. 56. There's no unit here. I don't think they have, oh, inches, yeah, sorry, inches. Inches. Now that's x, so we have to find this. So 2 times that. So 2 times 56. What's that, 112? 112 inches. So 112 inches. Same thing here. And then here, 3 times 56. Let's see, 8, carry the 1, 168. Yep, 168 inches. And don't forget the units there at the inches. And that's it. All right, so hope that helps. And let me know if you have any questions. All right, thanks for sticking with that, guys. And that was a longer video. Thank you.